So today we are going to start the concept of finite automata. Last day we have seen that how uh, different type of regular expression possible we have. Now, so let's start with the formal definition of finite automata first. By the way, before that, uh, we let's try to realize that actually what we are going to do with this finite automata, that we will actually go back to the problem that we have discussed at the very beginning of the course, that is set membership problem. Because we have seen that a program, if you understand, if you in a practical situation, if you consider, a program is basically a string, and the language that a compiler follow, language is basically a set. So a compiler is checking whether syntactically a program is correct. That means you can say that the compiler is checking whether the string is within the language or not. That means whether a particular string is a member of the set or not. And that's why we say it's a membership problem. So the set membership problem for a language L is given a string X, we have to decide whether X is within L or not. So now let's come to a formal definition of finite state machine. Not definition actually, let's try to realize it from a example. So we know that a finite automata is a finite number with a finite number of states. It's called finite automaton. And this automaton and automata, these two words we will use frequently in future. But there is a very small difference between these two words. Automaton is actually a singular form, and automata is the plural of automaton. But don't mix up or don't differentiate these two words, because we can use interchangeably these two words. Now, suppose, let's take an example of to realize what a finite automata is and how it works. But suppose there is a alphabet sigma whose symbols are 0 and 1, and we want to design a finite state machine that will accept all the x made of this 0 and 1, any combination of x. That means the input to the finite state machine is a binary string where the string has even number of zeros. For example, these are some examples we have given. This one. So since it is any combination, there is no restriction about the order of these zeros and ones. Now you see in this example, this particular string contain 0, 1, 2, 1, 2, 3, 4, 5 zeros. So naturally this should not be in the language. But if you consider this string, the zeros are 1 and 2. That means even number of zeros. That means this string should be in the language. And similar case for this one. I'm sorry, I have a mistake. This is wrong. I should have this the number of 0 in this particular string is basically 0, and since we consider 0 as a even number, so that means this part should be in the language. This is wrong, so it should be in the language. So now question is that how, that means this string should be accepted, should not be accepted by finite state machine. This should be accepted by finite state machine, and also this should be accepted by the finite state machine. So now question is that how the finite state machine will be designed. But before that, how you will say that the string has even number of zeros. Of course, you can say that, okay, I will write an algorithm that I will start from the leftmost symbol, and for each and every, at a single point of time, I will change my position to right once, and I will just count the number of zeros, and if the count value modulus 2 is equal to 0, that means the count value is even, so there is even number of zeros. But I want to show you a different type of way to realize how finite state machine works. Suppose, assume that you have a situation like you starts from this symbol, and for each and every step you will read one symbol at a time, and in this way when you will reach to the last symbol, then your answer should be ready automatically. You don't need to compute the number of zeros. So what I mean that this is a situation that I am trying to express, that you have some input string over here which is present in a tape. So assume that this is a tape, and this single part is a cell of the tape. A single cell contains one bit of information, that may be 0 or maybe 1. I mean, at most one symbol can be present. Actually, exactly one symbol can be present in a particular cell, and combination of many cells creates a tape. So the input that you have, some arbitrary combination of ones and zeros is present in this tape, and assume that you have a controller over here. The controller contains a read head, and that read head reads the symbols one by one, and at the very beginning, at the initial situation of the read head is somewhere over here. That is, the controller is not still started reading the characters. You are about to read the character of the tape. Now what we are saying? We are saying that we will go over this string one symbol at a time, and when I will reach to the last symbol, when the read head will reach to the last symbol, that means the string will be entirely scanned, the answer should be ready. How it is possible? You see a very interesting situation over here, that we are not going to count the number of zeros or number of ones. Rather, we will try to memorize how many zeros, whether we have checked, we have found even number of zeros, or we have found odd number of zeros. For example, when your reader is somewhere over here, you are about to start reading the characters, even the leftmost symbol of the tape. Then if I ask you that how many zeros you have encountered, you will say that the number of 0 you have seen is 0. So since 0 is even, we consider, that means at that point your state of mind is saying that you have seen even number of zeros. And then when you will read the characters, this first character, you will see it is 1. So your initial state of mind was you have seen even number of zeros. Until and unless you will see another 0 again in the string, your state of mind will not change, because reading any other character other than 0 doesn't have any impact on your state of mind, because you are only checking the either even number of zeros or odd number of zeros. So when you will read this character 1, you will see it remains same because it's 1, it's not 0. Again you will move right once and you will read this character and you will find a 0. So your initial state of mind was even number of 0. Now even number of 0 means it can be 0, it can be 2, it can be 4, it can be 6, it can be anything, any value which is even. Now what is the number of value, that is not important. Important is that whether that is even or odd. That is why any even number, if you concatenate a 0 with any even number of zeros, then as a whole it will become odd number of 0. So that means as soon as you will visit this 0, your state of mind should change from even number of zeros to odd number of zeros. Now what is the exact value of the odd number of 0, that is not important, because we are not interested to see how many even number of zeros is present in the string or how many odd number of zero present in the string. We are interested only even number of zeros present or not, or odd number of zeros present or not. Anyway, so with this state of mind, if you go right again, if you move on towards right again, you will see again a 1 is encountered. So it is not changing your state of mind. Again you have encountered 1, you will not it's not going to change your state of mind. And again when you will see a 0, so before reading this 0, your state of mind was you have seen odd number of zeros. And any odd number of 0, if it is concatenated with a single 0, as a whole total number of zeros will become even again. So as soon as you will visit this 0, your state of mind will change again from odd number of zeros to even number of zeros, like this. And in this way, depends on 0 only, since you are toggling your state of mind, ultimately at the end of the string, after reading the last character of the string, your state of mind will be either even number of zeros or in odd number of zeros. If your state of mind say that you are on odd number of zeros, then the machine should not be accepted. I mean the string should not be accepted. And if your state of mind say that you are in even number of zeros, then that particular string should be accepted somehow. So basically what we have seen from this example, from this elaborated explanation, we have seen that we are playing with our state of mind, where we have two state of mind, either it should be even number of 0 or it should be odd number of 0. And the string is something like this that we have in the tape. and among these two states, one of the states should be the initial state of mind, right? Since we are concerned about the even number of zero consideration, that means before we, as we have, I have already told you that when your read head is somewhere here, you are about to start reading, the number of zero that you have seen is zero. We are not care about number of one, because in the question or the language that we are considering for accepting in the finite state machine doesn't care about the number of one, it care about the number of zeros only. So that's why we will see about only zeros, not one. So that means number of zero, that number of one, how many number of one is encountered, I mean before, I mean we start reading the first character doesn't important. What is important now, what, how many number of zeros you have encountered. How many number of zeros means whether even number of zeros or odd number of zeros. And we can see that basically number of zeros you have encountered is zero, which is even. So your, that means your initial state of mind is even number of zeros. And let's just do it, then it will be much more easier to realize. So suppose that your state of mind, I'm sorry, your state of mind is saying something like you are present somewhere here initially. So at that time your state of mind is you are here, and when your read head will read this one, it is a one. If it is one, then your state of mind should remain in the same state, because this visiting one doesn't change your mind about the number of zeros you have encountered. So how I can express this? We can express with a circular arc with on this state, something like this. Mean your state of mind is where, if you are in this state and if you encounter a 1, then it is not changing your mind, your state of mind remain in this state. So you are over here, fine, and then your read head will move and come here. And we have seen that, I have already explained you, that if you have seen some even number of zeros and if you see a zero, if you read a zero, another zero, so as a whole number of zero that you have encountered should be odd. So your state of mind should change from this even number of zeros to odd number of zeros. That means your state of mind will change from this state to this state if you have seen a zero. Now, after coming here, what will happen? I mean, due to this zero, your state of mind change from this even to odd, fine, and then your read head will move towards right once. So your read head will point somewhere here, and the on this one, reading this one is not again changing your current state of mind. What is your current state of mind? Your current state of mind is you have visited odd number of zeros, because after reading this zero your state of mind changed, and your now current state of mind is you have visited odd number of zeros. Reading one doesn't change your mind. So that means if you are in this state and if you see another one, you will remain in the same state. Again you will get a 1. It doesn't again changing your state of mind. So you are again in this state. No issue. But as soon as you will see a 0 again, your current state of mind is saying that you have already visited odd number of zeros, and if you get another 0 over here, if you concatenate this 0 with the previous number of zeros, previous odd number of zeros you have seen, total number of zeros you have seen will become even. So that means at that point your state of mind will change again from odd number of zeros to even number of zeros. So that means we will have a transition from this state to this state. Just if the number of zeros they have encountered is equal to 1. I'm sorry, if it is 0, why 1? I'm sorry. If the 0, if the character that it has seen is 0. Now, due to this 0, it came here, and I have got a 1 again. So, if I got a 1, then your current state of mind is you have seen even number of zeros. And due to this 1, your state of mind will not change. Yes, it will not change, it will remain in this loop. Due to this loop, you will remain in this state. And then if you visit, if you visit another 0, your state of mind will change from even number of zeros to odd number of zeros again. So let's do one thing. Let's suppose that we are taking the problem is just a different, a little change I am doing. Instead of even initially, let's try to realize it from odd number of zeros. Okay. So x has odd number of zeros. So your initial state of mind will not change, obviously. Your initial state of mind will always be even number of zero, because when you are in this particular your reader is about to start reading, you have seen zero number of zeros. Zero number of zeros means even. So your initial state of mind is not going to change for changing the output of the or requirement of the problem. What will change? Due to from since I've changed the requirement from even to odd, that's why the final state will change. Final state mean, let's see. First point is that since this is our initial state of mind, how I should express it? Somehow I have to express this among these two states, that this is the initial state that we express with an array. With an arrow. So the state which is connected with a arrow blindly coming from us, from coming towards this particular state, that represents the initial state of the system. That means when you are about to start reading the string, what is the initial state of mind? And then after reading this 1, I have seen that I will remain in this state. Then reading 0, I will go this side, and with all two ones, due to this 2 1, I will remain in this state. And then I will, because of this 0, I will come back to this even number of zeros again, and then for this 1, I will remain in this particular state. And then 0, due to this 0, I will jump from even number of zeros to odd number of zeros again. And you see, after reading this whole character, since your state of mind is within this odd number of zeros, that means after reading this character, you will say that yes, this string should be within the language. This string is correct. So the finite state machine should accept this string. Why it is correct? Because we are considering that situation, that we are considering the language x has odd number of zeros. So the finite state machine should accept those strings which should have odd number of zeros. Now how I can express this acceptance? We can express this acceptance with the help of, just like we have kept array as a we have kept the arrow for initial state, we will consider a double lined circle, something like this. A double line circle, this is one line, this is I mean already there was a line and this is another line, a double line circle that will represent that this is a final state. So after reading some string, if ultimately you are in this state, that means finite state machine has accepted. So finite state machine will accept those strings which, on reading those strings, if the read head, if the state where the machine belong is in one of the final states, then the finite state machine accepts the string. So that means if I say that I have a string something like 1 0 0 1 1 0 1, you see I have odd number of zeros over here, right? So let's see what will happen. If I say that this is my string, something like this, right? And you are about to start reading the string, somewhere your read head is somewhere here, so that means you are in this particular even number of state, in this state, your initial state of mind, state of mind is somewhere here. Now on reading this first one, your initial state of mind is not changing again because you have not visited any zeros, so your initial state of mind, even number of zeros, remains same. But on visiting this second character, that is 0, your state of mind will change from even to odd. Fine. On reading this second 0 again, your state of mind will again change from odd to even. Now, after reading these two zeros, because of these two 1, your state of mind is not changing. So, your state of mind will remain in this even number of zeros. And on reading this 0 again, you will see you will come in this state. And you have odd number of zeros. So fine, you are in odd number of zeros. Now assume that I have another 0 over here. So what will happen? After reading this 0, you are in this state. And when reading, after reading this 1, you will remain in this particular state, right? But again reading this 0, your state will change from this odd number of zeros to even number of zeros, and here it ends. So after reading this character, the finite state machine will see that the state currently where the machine stops is in the state of even number of zeros. But this state is not a final state. If it was a final state, it should be within like this one, like double circle, double circle, uh, double boundary circle actually. Since it is not in final state, so machine will not accept that string. This particular string will not be accepted by the finite state machine. So this is how actually we can say that finite state machine can works.